welcome back. So in this lesson, we're going to be talking about unit rates and slopes and how they relate to each other. So let's dive right in so this doesn't take very long. So a rate is a ratio. Remember, slope's also a ratio that describes how one quantity changes over another quantity. So basically what a rate is it is slope, but with units. So instead of our graphs being just lines, here our graphs actually have units to them. So like this plant club, and we had plant height and weeks. So we're inches to time here, inches per week type of relationship. So we find rate the same way we find slope. And so if you remember, slope is the change in y over our change in x. Now the other thing to keep in mind is, and especially let's look at this example that we have here, our units for our x and our y can be different. So I cannot just count boxes and say, okay, well this is 2 units up and 3 units right. And the reason I can't do that is because my up is going by 4s, my y's are going by 4s, and my x's are going by 1s. So it really can make this more simple if you do the method of using 2 points. So we have the points 3, 6, and 0, 2, and so my suggestion, instead of counting our rise over our run, is that we'll take 6 minus 2, right? Y minus y over y minus y over x minus x. So since I did 6 first, I've got to do 3 first and do 3 minus 0. Notice again our 3, 6, and our 0, 2 line up. 6 minus 2 is 4, and 3 minus 0 is 3. And so we get a rate of 4 inches every 3 weeks. Now, it could ask for a unit rate, and if it asks for a unit rate, that's us wanting to know how many in 1. So our bottom number, if we're doing a unit rate, our bottom number is always a 1. And so how we would figure that out is by taking 4 and dividing by 3. And so 4 divided by 3, there's my, would give us, would give us a unit rate of 1.3 inches every week. So this is just a rate. So we're going to write this over here where we have more room. Rate would be 4/3, and a unit rate would be 1.3. So 4 inches every 3 weeks, unit rate being 1.3 inches each week. Okay, so let's practice. Example 1. The graph shows the amount of milk used to make a particular cheddar cheese. How many ounces of cheese can you make per gallon of milk? Now, this is what we call a proportional graph because it starts at 0, 0. That's just something to kind of have in the back of your head. So this is proportional. That also means we have a constant rate of change. So I know that this point down here is 0, 0. And I know that this point here is 2, 32. And so I'm going to do my subtraction. 32, so y minus 0 over 2 minus 0, which will give us 32 over 2. And then we should always simplify. So 32 divided by 2 is 16. So we can make 16 ounces per gallon of milk. Per And so this is 32 over 2. It is considered a rate. 16 ounces is considered our unit rate. But that's how we find how many ounces of cheese we can make per gallon of milk. So we found our unit rate given a graph. All right, next problem. Example 2. Your neighbor burns 88 calories in 8 minutes. Cross-country skiing. There is a proportional relationship between calories burned and time. So again, that just means that we're starting at 0, 0, which makes sense, right? If I haven't exercised any minutes, then I have not burned any calories going cross-country skiing. So what we want to know is what is the unit rate of calories per minute. And so to find the unit rate, we know that we burn 88 calories in 8 minutes, right? Calories, minutes. So we want to know how many calories in 1 minute. And so I'm going to divide both by 8. And so I end up with 11 calories per minute. Now, we're going to use the unit rate to draw a graph that models this situation. Our horizontal axis is going to show time, so we're going to label that. We should always label in minutes. And our vertical axis is going to show total calories burned. So, total calories burned. All right. And then we've got to label it. So we know that this is going to be 0, 0. I am going to do my time, my x, by ones, 1, 2, 3, 4, etc. And then I'm going to do my y's. I'm going to do them by 11, because that'll allow me to fit more into my graph. 11, 22, 33. And then I am going to pause my video to finish making my graph so that you can also make your graph at this time, but you don't have to watch me struggle through making a graph. So, pause. All right, so I finished labeling and I've gone ahead and put my points in. But what I want to do is talk about how I got my points. So I know that for every minute I burn 11 calories. So I make a table. And my X, it's a T-chart, X and Y. I know my first point is going to be 0, 0. For 0 minutes of cross-country skiing, I have burned 0 calories. And then for 1 minute, I will have burned 11 calories. And then for 2 minutes, I'm going to add another 11, right? Because I'm going to burned another 11 calories. So that's going to be 22 calories. For 3 minutes, I will have burned 33 calories. I can also think of this as the equation y equals 11x. And we haven't really talked about that, but that's what I'm thinking about when I go to graph. That for each minute, if I plug that in, 4 times 11 is going to give me 44. So that's how I came up with my points. Now, we're going to use the unit ratio to draw a graph. We already did that. It shows the total calories burned. And now it's asking what is the slope of the line? Well, slope of our line, and we're not going to count box over box because remember this box up is 11. But our slope is the same as our rate. Our slope is going to be 11. And that is the slope of our line. I hope that helps on the graphing point. Again, I like to make a table and it's a constant rate of change. So I'm going to add the same number to each of my numbers in the Y column. All right, moving on to our last example. Your friend borrows $200 from her parents. The graph shows how much money she owes her parents. How much is she repaying her parents per week? And how long will it take your friend to repay the loan? So the amount she is paying her parents per week is going to be the amount we go down each week. So what I'm going to do is I'm going to find a second point on my graph that crosses at what I like to call the crosshairs or 4 corners, right? It would be where a 4-way stop would be if these were roads. And so I'm going to put a point here. That point is 2, 160. And then I'm gonna use our starting point, the fact that she borrowed $200 from her parents. Oops, not 220, just 200. All right, and then from here, I'm gonna find my slope, our rate of change, right? So we're gonna take 160 minus 200. So since I took the 160 first, then I'm gonna pick the 2 second, 2 minus 0, right? So 160 minus 200, 2 minus 0. I've got my 2 160 and my 0, 200. And then 160 minus 200 is a negative 40 over 2 minus 0 is 2. And negative 40 divided by 2 is a negative 20. So what that means is she is paying her parents $20 each week. So that answers the first question. How much is she repaying her parents per week? The second question, how long will it take her to repay her loan? Well, we know that her total loan is $200, and we know that we are paying $20 per week. So I'm going to take 200 divided by 20, and that is going to give me 10. And so it will take her 10 weeks. And that's how we use rates of change or slope to solve real world problems and to give us our rates of change. So I hope that this finds you well, and until next time.